So here's a quick recap. I ran Nikto and Nuclei in the last video and saved their outputs. Now we'll turn those raw outputs into prioritized, validated vulnerabilities you can act on. This is the triage, separating noise from the real exploitable issues. And here's a reminder, do not run these tools against production or third-party systems without any permissions. So vulnerability scanners, as we all know, generate noise. Good triage ensures your time focuses on issues that are exploitable and impactful. You want to reduce hundreds of findings to the handful that could lead to a compromise. So a simple funnel here is scans directed to triage and then directed to validated finding. So let's walk through a typical scanner finding and what to extract from it. Any finding should include the title or the identifier, evidence, severity of the CVE, reproduction steps, and most recommended remediation steps. Here's a simple nuclei result. As you can see, there is CVE mentioned, the template, and the severity as well, along with its evidence. HTTP response, MASH pattern, and all of those evidences. We need to extract the CVE, the request response evidence, and the template name here. That's your seed for validation. So CVSS is a numeric score from 0 to 10 describing a vulnerability's base severity. And this I'm explaining for those who are not aware of what CVSS means. But CVSS alone doesn't give you the priority. Always contribute CVSS with exploitability and the business impact. So my quick formula here would be priority score equals to CVSS into the context factor. So for example, we can just say CVSS 9.0 to 10 means critical. Or we can say CVSS 7.0 to 8.9 means high, CVSS 4.0 to 6.9 means medium severity, and CVSS 0.1 to 3.9 means low severity. But here the part is scanners can be wrong, and to validate a finding, you need to follow these steps. Reproduce manually, capture the request and response, and confirm the impact in a lab response or a lab snapshot. Manual checks use simple tools like a curl, a browser, or even burp suite. So let me just run some curl commands for you as a demonstration of manual checks. If the curl command returns a 200 for the PHP myadmin, you've reproduced a scanner finding. Save that request and response and screenshot for the evidence packet. Now let's understand the prioritization matrix and how to use it. The simple use of prioritization matrix is to keep three things: exploitability on a scale of 1 to 5, impact on a scale of 1 to 5, and the exposure on a scale of 1 to 5. And then to get the priority score, you need to multiply the three. For example, we have an internet exposed RCE vulnerability, and the exploitability will be 5, impact will be 5, exposure will be 5. And then when we multiply all these three together, we get a score of 125, which means critical. And this tells us the higher the score, the more urgent the case is. For example, an internet-facing RCE vulnerability with CVSS 9.8 is really urgent, and a local info disclosure with CVSS 7 but accessible only internally might be at a medium priority in your scope. Always state the exposure and the affected asset in your report. Now let's build your evidence packet. Every evidence must have the scanner output report, manual reproduction steps, which are curl and scanners, and the timestamps, suggested remediations, and the priority score from the priority matrix. So here's an exercise for you all. One Nikto and one nuclei finding from your lab must be picked. Manually reproduce each with curl or the burp suite. Create an evidence packet with a 1-paragraph remediation and a priority score using the priority matrix. Save your artifacts to your directory and commit to your repo. In the next video, we learn how to pick exploits to validate safely and how to use check and non-destructive POCs in your lab. Like, subscribe, and push any redacted evidence to your GitHub so I can review it.